right, welcome everyone. Got a phenomenal turnout. I'm really excited for that. My name is Ryan Stratt. I'm the president of RoboJackets. Normally you'll see Sarah Storer up here. She's the one who's been sending you a lot of the emails along with Christoph's. There are two outreach project managers. Sarah's out in Colorado today competing with our Robo Racing team in the Spark Fun Autonomous Vehicle Challenge, so she'll be here next week. So first of all, thanks for coming. Thanks for everyone who's joining us via the live stream. We appreciate your patience for the short delay in getting that set up. Our speaker today will be Trevor Davidson. He's been a mentor for 2 years now with Team 1648 G3 Robotics.
Yay!
So it's kind of a first time for me, so if I screw up, don't hold against me. But yeah, so I've been doing CAD for about 5 years now, since the beginning of my high school team, which I started in my freshman year. And I'm a second year mentor on G3. I'm the CAD and strategy mentor for the team, and my role kind of encompasses trying to teach kids CAD, to teach the rookies, to teach the new kids. So we have a strong design base every year, and my other role is to lead the strategy efforts during the competition year. So I'm pretty familiar with CAD. I've done 5 years of Autodesk Inventor, about a year plus of SolidWorks, and I'm familiar with a couple other programs. Currently, right now, I'm co-oping at Electrolux in Anderson, South Carolina. So I've got a little bit of real-world experience too to go along with it. So hopefully this presentation is a little bit more informative than I hope it'll be for you guys, but it is a lot to cover, so I'll try to go as slowly as I can and still get to everything important. So really the big thing to talk about is why do you use CAD? What are you trying to get out of this program? It's really what you make of it. So a big source of CAD prowess is documentation. You can really store an entire worth of robots files in one folder, and that's pretty awesome. When you think about it, you can probably do it in about 3 gigabytes or less. So it's kind of incredible that you can keep all that information in, but you really need to keep it organized. CAD helps you do that, but it's up to you. Other things about it, precise design. You can send these parts on water jets, you can send them to CNC mills, you can send them to any kind of machine, and you should be able to create an interesting part file with complex designs. For example, last year for our intake plate, I don't know if you guys saw this, but for state competition we did the whole 1648s scribbled out in our intake, so for states. So you could create kind of really cool things like that. Geometric conflicts and inconsistencies. When you do something in a sketch, sometimes you don't always see where things are going to collide with one another, where chain links are going to run, where belts are going to travel. Doing this in CAD can make a huge difference into seeing, hey, there's a conflict right here. We're going to need to make this a little bit taller, make this a little bit shorter, make this a little bit wider. So that's a huge benefit. And then lastly, it's a real-world engineering tool. Like I said, I'm working at a co-op right now, and all the time, every single person uses CAD. Now granted, I'm an engineer. Not everyone in this room is going to become an engineer or is an engineer. But at least for FIRST Robotics and for our purposes, this is a real-world tool, and it's really helpful, especially if you pursue engineering. So today we're going to cover a few topics. This is kind of the fundamental session. Next week is going to be the in-depth. These are going to be the cool the really cool, hey, this is how you do a belt, this is how you do stress analysis, yada, yada, yada. Today we're going to cover the fundamentals. So this session is more geared towards beginners, people who are just starting out. So I hope you guys are going to get something from this. But if you do, that's great. Navigation is going to be the first thing. We're just going to cover the layout of the system, where do things go, where are things, and then we're going to go to sketching, 3D part modeling, assemblies, and if we have time, we're going to cover working drawings. But that's pretty ambitious, so we'll see where we get. So I have 3 critical points today, and if you take nothing else from this session, and you might not take anything, but take these 3 things. CAD is not a tool for prototyping, and it is not a tool for coming up with ideas. The idea creation is not, CAD doesn't just, you sit there, you open it, and wow, all of a sudden it builds a robot for you. That's not how it works. You have to come up with the ideas in your head, and then you have to transfer that to paper, and then transfer that to CAD. Because if you start trying to rely on CAD to create things, it is way too detailed in the software, and way too detailed in an interface to get you anywhere useful. What you need to do is take your time to sketch things out on paper, and then go into CAD and figure out the fine details in that order. Don't try to do CAD first and then sketch things. Secondly, there are many ways to do everything. I'm going to teach you how to do rectangles in 4 different ways. That's a lot of different ways to do rectangles. None of them are necessarily the right way, and none of them necessarily are the wrong way. So just because someone does something differently, or I do something differently than you do, doesn't mean you're doing it wrong. It just means we're doing it different ways. Some things will be more efficient than others, but over time you'll kind of see that. And lastly, figure out what you want to do before you do it. That's kind of the same idea as don't prototype, just kind of randomly. Just don't CAD before you sketch. But along those same veins, it applies to everything. If you don't know what grabber you're going to design for the 2017 game, you're not going to design an effective grabber. You're just going to be like, oh, I'm going to design a grabber. Well, why do you need a grabber? What about an intent? What about a shooter? There's many different ways to look at this. And so you want to figure out what you're doing before you do it. So we're going to go right into a demo. It's kind of going to be up on my screen, so if you're following along on your computer, please feel free to. I'm going to start just looking at some the navigation part. Okay, so first thing I pulled up is this view cube right here. Basically what that is just to help you guys how to get a visualization of the part modeling space. Think about the part modeling space as if you were in the real world. You know, everything has kind of height, width, and depth. This presentation remote control thing has height, width, depth, 3 dimensions. And that's kind of the same idea here. And you kind of view it as if you're looking at a square, which is why I made a square here. Everything's going to have a front view, a top view, a right side view, yada, 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 just like if you're looking at a 6-sided die. So the square kind of indicates, for me, the front, the triangle, the top, the slot, the left side. So it's more just helping you guys figure out this workspace. So getting around CAD, everything's going to fall under these sections of the tabs. And underneath the tabs, you're going to have buttons, and then beneath those, sometimes you're going to have these drop-down menus. And we're going to give you tons of options. They can be hidden in places, but hopefully I can give you guys some insight into where to find the most important stuff. And then navigating around the workspace. So you'll see in the top right corner here this view cube. Basically, this is how you're going to navigate yourself in Autodesk Inventor. So if you click the front view, you'll see that it highlights itself blue. That means you're getting ready to click it. If you click this, for example, if you click the top left corner, it'll go to the top left, or the top right, top left, same thing. Keep in mind though, it's not going to always go to the orientation you want. So if you click the left side and then kind of click the bottom corner here and then try to click that corner, or it could end up in a kind of funky state like that. So just make sure when you play around with this, you're going for the state you want and not for the state that just, if you click the view, it should automatically go to the one you're thinking of. But the one thing that does make it a little bit easier to get to where you want to go is if you click and drag. So I'm just going to click and I'm not going to let go. You can see it's still highlighted blue. I can kind of pivot around the center point of wherever I'm looking. That's going to give you kind of an orbit. So if I want to look at this corner from this angle, I can do that. And if I want to return to the front view, you can see it's kind of tilted again. I can do that as well. My caution for you when doing this is, if you right-click, let's say I wanted to set this as this view is my front view, right? Right-click, set current view as front. Simple enough. But if you try to do that when it's kind of off kilter, like this, and you do that, your front view is going to be set as kind of off kilter, so every other view is going to be equally off kilter. So make sure that when you change your view settings, doing this, as I said, right click, change it, you don't set it at this odd angle. Other critical navigation features, you're going to find most of what you need in this bottom corner here, and if you don't click this button right here, it should have all of the critical features. But the other useful ones, you got pan, which kind of just pushes things around the screen, click and drag. You also have the zoom features, and you've got multiple of those, but I'm just going to kind of cover the ones I use mostly. Zoom all is going to make it as zoomed in as possible for whatever side you're looking at, whatever view you have. And then lastly, zoom window. If you click the Z button on your keyboard or underneath the drop-down menu, zoom window, that'll get you pop up this kind of screen. You can see the blue lines on the screen right where my cursor is, and that should make it easier. And then if you click and drag, it'll pop up a window. You can still see sort of the blue lines. And that'll move your screen into wherever you're selecting. So just some basic navigational tools that I'll try to use. I'm going to use that throughout the feature, so if you guys get confused, feel free to speak up. Probably the last thing is the home button is kind of one of the most fundamental tools. And you see me, I've been using it kind of regularly here. If you click F5, it does the same thing, so don't worry, there's a hotkey for that. But the way to change it also, let's say I wanted to make this back corner of my home. If you saw the right click, you said set current view as home. It gives you two options. Fixed distance is going to set whatever you're looking at right now. That's going to be your home view, and it's going to be at that distance. Fit to view is going to play it so that if you click home now, okay, it's not cooperating properly. So if I click home now, see it zooms in as far as it can. So that's going to kind of be the critical navigational features. So we're going to go right into general sketching. So when you open up the main window, you're going to have this kind of screen. I'm using Autodesk 2015 right now. If you use 2016 or 2017, it could look a little different. But these are the window you're going to pop open. Generally, you're going to kind of go with a part. So in this case, we'll just click the standard part. Sheet metal is kind of the same thing. It just adds another drop-down tab. So it doesn't really change too much, and you can easily change it to a sheet metal part, but we'll cover that next week. So how do you start to make parts? Basically, there's this little button right here in the tab that should open up called Start 2D Sketch in the top left corner. You can click that or use the hotkey S, and I'll pop up these planes. What are these? These are the original planes. And what I mean by that is each of those planes intersects the origin of your part model space. So they're going to kind of be your fundamental starting point for anything, but they don't kind of get stuck on that concept because they just matter for the beginning. They don't really matter past that unless you need them. So you can kind of skip that for now. I'm going to click the XY plane, and that's based on these little axes in the corner right here. So you can see the XY is kind of up and to the right. I'm going to click the plane that's up to the right. Just highlight it and then click, and it should start that sketch. And you can see the X and Y axes are right there. So how do we get this started? What we're going to do is we're going to make a stick figure, because I feel like that's a really good example to show everything we need in sketching. So how do you start with a stick figure? Well, generally I start with a head. So what are we going to use for that? We're going to use a circle. You can see that it has a drop-down menu too. It's got a few different options. We're going to stick to circle center point today, because the other ones are much more situational. But for right now, stick with center point. So we're going to click. That's how you place the first point. The center point is when you click. And then if you come and drag your mouse, you're going to see that the circle expands. If you click again, you can set it to any size you want. It doesn't really make a difference. But if you want a precise input about the diameter in this case, you can put in any number. You'll see if I put 0.5, it'll put 0.5 there. And then it'll put a dimension on the 0.5. And let's say that circle is now fixed to a half an inch. I can obviously come back, change that, and just place it at any dimension I want, though. So it's up to you how to do it. So we're going to place that circle. And then we're going to go to line. So like I said, there's many ways to do things. Line kind of is the basic level to do all of them. And similar to how a circle, it's 2 clicks to create a circle. It's basically 2 clicks to create a line. So we're going to click right beneath the circle. Go down, that's his body. 2 arms. Now you'll notice something as I'm clicking the lines. There's like a second line created. If you don't, so sometimes it'll fix a point and you'll select a fixed point and that'll kind of kill the extra line. But if you select any point in space randomly, you can kind of just select another point and it'll create another line with the second point you clicked being the base for the second line. So clicking escape kind of gets you out of any tool. So just if you need to, click escape, get out of it. And then Control Z is your undo. Pretty straightforward. Everyone should be pretty much familiar with that. So then 2 legs. We're just going to kind of set them as whatever for now. Nothing too special. All right, so those are kind of the critical things. And there's another drop-down menu underneath the line, so splines and control vertex and equated curves. A lot more complicated than it needs to be. And I'd say if you guys get time later, check out some splines. They're pretty cool. But again, not that critical. Lines are definitely more important. All right, so we're gonna create a couple of rectangles too. And rectangles are just, like I said before, you can create, there's multiple ways to do everything. Rectangles are just 4 lines. So there's a couple different versions of rectangles and slots and polygons, and we're gonna kind of stick to the 4 rectangles for now. We're gonna kind of ignore slots because they're kind of the same thing, just a little bit different. But looking at the rectangles, you gotta get 4, you see there's like 4 different versions and they all kind of mean different things. But they generally do the same thing, they just have different implementation. The 2-point rectangles, including the 2-point center, are just going to be horizontal and vertical lines. So you can't rotate them in any regard. A 3-point is going to be off kilter. So instead of being just straight horizontal and straight vertical, it's going to be kind of a 45 or a 30-degree angle, like so. I click the 2-point rectangle, and I select the first point. I can select the second point right now, or I can do the precise input. And if I tab, I can switch between the 2 options. So let's say I wanted to do a 1/16 of an inch and a 1/16 of an inch. Here's your rectangle. And then the 3-point, select the first line, select the second one. Looks like you're just creating a regular line, right? You are, and then you're projecting the rectangle based off that. Pretty straightforward. The center ones are pretty similar. They're just, instead of clicking the line first, you're clicking the center first. So it doesn't really make too much of a difference. Those are kind of the basic rectangles. All right, so one of the things that makes CAD really cool is it's not just a SketchUp. If you want sketching, Google SketchUp, piece of paper, do plenty of that. But what makes CAD great is you can input dimensions, you can put constraints, and it fixes things together. How do you get there? You can see this little box right here. It says constraint underneath it. That's going to be your go-to source. And you can see a bunch of little tabs. We're going to start with the most important one. It's the biggest one. It's dimension. Dimensioning is the fundament. It's the most important constraint. But again, it's a constraint. So what does that mean? You cannot over-constrain. If the program will not allow you to, it'll say, hey, you're over-constraining this. Don't do this. I won't let you do this. But you can over-dimension things. Case in point, if I wanted to dimension the diameter of the circle, I don't need to specify the radius of that circle at the same time. So you can over-dimension pretty easily. CAD will recognize that sometimes, but not always. And you can use these constraints to the right, where these little tiles are, to help you do that. So using a dimension, it's pretty straightforward. If you click a circle, it should pop up with the appropriate dimension. It should be a diameter, but that's pretty easy. If you want the placement of the circle, you click the center point, and that'll create that kind of a vertical or horizontal dimension, depending on where the circle is. But let's say you just click a random line. And you can see that's kind of like an odd angle, right? Because we want his arm to be a certain length, not to be a certain length from the body. We could do that, but one thing that would probably make a lot more sense is if we right-click, you can see it gives you a few different options. Kind of ignoring the ones up here, you've got these 3 aligned vertical and horizontal. Right now we're in a horizontal dimension, it's measuring in the X. But if we want to go and change that so we get the actual length of his arm, we're going to want an aligned dimension. Like you can see now it's along the length of his arm. And we can change that if we want a vertical dimension, it'll fix it to that, a horizontal dimension. Very straightforward. So let's say this is 0.5. It's kind of it for dimension. It's a pretty straightforward tool. There's nothing too special, but it's the rest of the tools that complement it. So one of the easiest ones to think of is a coincident constraint. Basically, you have a line, you can connect to a point. And you can connect a point to a point, but you need one point involved. So let's say you've got the center point right here. And I want to make his body fixed to that point. Now it is, because I click the point, I click the line, and now they're fixed together. Let's say I wanted to make the center of his head fixed to that line, that point. Click the center, the point, now it is. So that's the benefit of the dimension, is you need specific numbers for the dimension. The other constraints are all related to other things, which makes it really easy to put 3 or 4 dimensions in there, and then just connect everything else by some logic. So if we wanted to connect, again, we're going to connect this body to the point. So you see that line turn purple. So what does that mean? What can a purple line mean? Basically, it means that it is fixed in its movement. That line is not going anywhere. It is set. It is done. Nothing that important about it, but that's kind of the general gist of it. And there's a couple other really critical ones. So parallel and perpendicular I think are pretty straightforward. You pick two lines and they'll be parallel or perpendicular. Nothing too special. I'm going to demo that really quick with the perpendicular. Ta-da. And then you get to probably the most useful ones from my perspective are horizontal constraints and vertical constraints. Think of it like this. If you have 2 points and you want them to always be on the same line together, you use the horizontal and vertical. So for example, if I want his arms to always be, the end of his arms to always be at the same point, like kind of like this. Just like that, for the end of his arm there. And now if I click and drag his arms up and down, those two endpoints will always be in the same place. The similar idea applies with the vertical. So if I wanted to make his leg and his arm always coincide, now you can see that where his arm goes on the x-axis, his leg will follow. So those two are extremely useful because let's say you need to line up, let's say you're doing a hole pattern, and you need to line up a couple different holes across apart from each other. It's pretty easy to just connect the two like this. Other ones, the symmetry constraint basically makes things two equal across a line. So if I wanted to make these two equal, there you go. Now if I move this in any direction, it's going to mimic on the other side of the line. Equal constraint, similarly. It's over constrained. See what happened is that it got frozen. It got stuck. It means it was over constrained. The symmetry constraint is already there, so it skipped over. Other ones, tangent. If I wanted to click, you need to select one curved surface, so a circle, an arc, something of that nature, and then select either another curved surface or a flat surface, and for the tangent constraint to work. So click that, click there, ta-da. So those are kind of your most critical constraints, and I would say make sure you're not over-dimensioning something, because it can get really hairy with all these dimensions. If I can just demonstrate really quick. You can see how hairy it kind of got pretty quickly. The fewer dimensions, the better. It's going to clean up your drawing. It's going to make it a lot easier to read for someone to go back later and figure out. Okay. So then there are there's more to this than just rectangles, circles, and lines, obviously. You also got other cool things you can do with this. So for example, you see all these slots in the modify section. Say I want to do an offset. What does that mean? You're taking a part dimension and you're scaling it down or scaling it up to offset it from the original. So if I click offset and then I click his head, if I can just place it there, now it's offset. Every single point on that circle is offset from every single other point in that circle that's the same for a certain distance. So as you can see, if I do that again, and I enter 0.1, now the entire circle is offset 0.1 from that other circle, from the original. And these are kind of all along that vein. They don't fundamentally change any of the part, they just modify it some, again, hence the name. Move and copy and rotate are all kind of along the same lines. You select the geometry. So move, select the geometry you want, select a base point, and move it. So they're kind of all along the same lines. Some just copy, some just rotate. So those are pretty straightforward. Other things, so if you get trim, scale, extend, stretch, I'd say the ones that are most useful at this are trim and extend. Let's say I moved we'll call this his hand, for example. Place it right there. We want to use a trim and extend. So let's say we wanted to make his arm a little bit shorter just to fit his hand, right? It's kind of awkward to have your arm go through your hand. Click on the end piece right there. You can see it's dark gray. These dark gray dashes along where the line is. That means it's about to be cut. If I go over here, you can see that part's about to be trimmed. So it's all about where you highlight your cursor. So if I select here, it'll trim that part of his arm, and it'll create a coincident constraint right there for me. And similarly, with the extend, it's kind of the exact opposite. If I go over the end of this line right here, you can see a black preview of where the next part of the line is going to be. Click there. Now the line is extended. So these tools are kind of fun to play with. They're interesting, and you can kind of create cool stuff out of them. All right. Any questions about sketching before I go into patterns? Okay, cool. So,
Trevor, quick question. On the square, say I want to align to the midpoint of the square, or the midpoint of the center, like if I take it on one of the sides, if I want to align to the midpoint on that side,
oh, okay, yeah, I understand.
or
So,
the center of the square.
yeah, so you can use midpoints as well. If you, for example, let's say if we wanted to create a line, this would be a line, but you can see the midpoint is highlighted green when I scroll over this. Same thing with the endpoints. So they kind of do this green feature. So if I wanted to make the center of this square, like you said, or the midpoint of the square aligned with the center of his body, you said. Let's do a horizontal constraint. Let's click the midpoint there, midpoint of his head. You can kind of do the same thing with midpoints. So it's not just restricted to endpoints. Midpoints do work too. So patterns. These are kind of can be the most powerful tools in all of CAD because they create multiple iterations of other things you need to make without you having to do a single other thing. But they need to be used carefully because you can create odd patterns and create weird things. So try to use it wisely. It's not always going to do what you want to do. You need, like I said, you need to know what you're doing before you do it. So let's use a rectangular pattern. They're kind of all along the same lines from rectangular to circular. Mirror is slightly different, but they all create similar patterns. You need to select a geometry first. What are you trying to pattern? So let's say we're trying to pattern his hand. So we just kind of highlight all the parts of his hand. And we can click things too, at one at a time. You can't really unclick things though. So without clicking, but if you want to get rid of something, click Control-click, we'll get rid of things. And let's say we want to go vertically. So then you click the little direction button right here, direction 1. And you can see this little green arrow right here. It's tough to see, but it's kind of right there. That means it's going. That means the pattern is going down relative to from our viewing perspective. So if I want to flip that, I just click this little button right here, going up. You can see here's the pattern, multiple iterations. And let's say we want to change the distance between the two to be 0.5. There's your distance change. 3 iterations, 4 iterations. The tools are pretty straightforward, and if you ever need to remember what they're doing, just kind of scroll over it. It should tell you what it is. Yeah, see spacing between the two, 0.5. Let's say you wanted to do kind of a larger pattern, go in multiple directions. Well, I can click the direction 2, click that line, see that arrow's right there, and now I'm creating multiple patterns, not just one. So it's pretty cool. Pretty neat stuff, pretty powerful. If you wanted to create hole patterns, let's say you have a versaplanetary gearbox and you want to put a hole pattern in, that rectangular feature is going to do exactly what you want. You make one hole, it'll do all the rest. The only other really cool one out of this, the circular is pretty much the same, a little bit different stuff obviously with angles, but the mirror command is kind of the rest of it. So select the box, click mirror line, apply, and it kind of just works. Your mirror line is good. It's not going to, you can see I can slide it. It's kind of going to change with the mirror line. So as you can see, as the mirror line moves further, the mirrored feature is going to move, not the original one. So make sure you keep that in mind when you're doing this stuff. That's kind of it for patterns and sketching. So if anyone has any questions, that'll be a good time. Okay, cool. All right, so we're going to kind of move on to part modeling. Click the new again, go to standard, start with model space, and I'm going to kind of click the XZ plane this time. Go with the circle. It's really throwing me off. All right, so we're going to go with a circle. Let's say we'll make it 8 inches. So now we're let's say we're done with the sketch. We just wanted to use the circle. We want to make an axle. Click Finish Sketch. Home view kind of gives us this isometric perspective. See the 3D model tab, it's got a bunch of things. Extrude, revolve, sweep, pull, fillet, yada, yada, yada. Some with drop down menus, it's a lot of stuff. You gotta know, like I said, you gotta know what you wanna do before you do it. This time we're gonna kind of create an extrusion. And when you think about an extrusion, think about 80-20. You guys have used that before. It's kind of got the same pattern along the entire length of the object. And the idea is that you're forcing aluminum through a profile and creating that structure. This is basically the same kind of idea. Imagine just forcing whatever material you want through this profile, and that's what it's creating in the same vein. So what is a profile? It's just whatever kind of sketch you have. So in this case, it's just a circle. Pretty straightforward. If I created the 80-20 extrusion, it would use that. So we've selected the profile. With only one profile selected for you, so that's pretty straightforward. And since this is the first one, it kind of gives us some interesting extents. What is an extent? Extent is kind of how far the extrude will go. So if I wanted to go an inch, I want it to be 2 inches long, I want it to go from this face to this face, it can all do that. But because we're in the first one, we kind of need to give it some basic instructions. So in this case, we're just going to do distance. But like I said, there's 2 in between that can kind of change that. So in this first box is just the length you want, so 2 inches, 4 inches, 8 inches, whatever you want to put. In this case, we'll put 1.5 inches. You can put fractional in all of these dimension boxes as well. It should reach the same thing. And then you've got these kind of planes and arrows. And what do you do these mean? Direction 1 and direction 2 are kind of arbitrarily placed, just depending on where you're going. But they're kind of just opposites of each other. So right now we're in direction 1. If you click direction 2, it'll go in the opposite way. But I like to use, especially for my first one, I like to use this symmetric. And that'll place whatever, it'll divide whatever box thing you have in your distance box. Take that, cut it in half, and put it on both sides. So it gets your center point at the center of whatever your first extrusion is, which is, I think, is really useful. But let's say you want it a little bit differently. Asymmetric is also really useful. You can go down 1/2 inch and go up 2 inches, just for reference. And you can see, it's easy to see now, but it's even easier to see now. You can see there's 2 inches on one side, 1.5 on the other, and you can switch that. Let's say I want it the opposite. Click the flip button, it'll flip it for me. So there's a lot to play with here, and it gives you plenty of options. So we're just going to kind of go back to the original, symmetric. We'll say it's about 1 inch. Okay, done. Simple enough. It just looks like a disc now, right? But it's not really an axle. So let's kind of say we want to put a couple holes in this disc. So we hit a sketch, and we've kind of just worked with looking at the planes before with the sketch, but the cool thing about using these sketches, you can kind of use any face. So if we wanted to go back to the original faces, we can. The YZ, the XZ, and the XY plane, we can still do that. They're just under this tab right here, the plus and minus. But let's say we wanted to use the top of this disc. That's pretty straightforward too. Just click the disc. And now you've kind of created your workspace on top of your part model. So it's easy to cut holes in things or add on top of it. So it allows you to play with a lot of different neat stuff. So we're going to kind of put a circle, go back to our top view, put a circle kind of right here. We'll say it's about 1/2 inch. Use the vertical constraint to lock it down to here. So now you can see it only moves up and down. And we'll dimension that to be about 3 inches. Okay, cool. So we're going to hit extrude again just to show you guys. But basically, you can still extrude upward. You'll see this little box right here. It's called join. That's basically just a create button. It adds to it. It builds up. The opposite of that would be a cut, right? That's this little box right here. Cut goes the opposite direction. It takes away material. And it gives you a little bit different options with your extents. So for example, if I'm in join, you see this all button doesn't really do anything. It just goes to the other side of the part. But since there's already part pieces there, it doesn't make much of a difference. However, if I go to cut, now it'll cut the entire part of that section, all of it away. So click OK. You can see there's a hole there now. Let's go back for a second though. Because there is a hole feature for this. And you can use extrude for a lot of these holes, but hole feature is going to kind of distinguish things in that left side box. So click hole, and you'll see it gives you a whole different drop-down menu. It gives you a lot more to play with. For example, right now, if you just do an extrude, you're basically doing the same thing as a drilled hole. And if you're just doing drilled holes, fine, do extrusions. It makes no difference. But if you're trying to do countersinks and counter bores, it makes it a lot more easier to do it in this whole feature. As you can see, we can select counterbore, we can select spot face, and we can select countersink. So it gives us a lot more flexibility to do things all in one motion. Let's say we want to do a counterbore hole. And a counterbore hole is just like a hole, a flat surface, and then another hole straight through, as you guys can see in the picture. And you can see we can play with the dimensions here. So the dimension out here in the circle cannot matter. I can keep that at 0.375. I can keep it exactly how it is. And I can go to centers. The placement is from sketch, so then I would just kind of select my circle center. Click OK. And you can see it's got that little counterbore inside. Pretty neat. But let's say I wanted a countersink. You can kind of do the same thing. So it can easily combine something that would take a lot longer to do into a short period of time. But like I said, if you're just doing a drill hole, the extrusion doesn't really make too much of a difference either way. And if you have different ways to place, you can use different ways to place a hole. So I made a sketch. That's one way to do it. But you can do a linear one. So especially if you have a rectangular part, you can create the dimensions in the whole feature, and it'll do that by itself. Concentric, it'll kind of find a circle. You can click the circle, not the center point, and it'll work. Or on point. I generally try to stick to 4 sketch linear and concentric, but that's up to you guys. Those are kind of the most important things. And then you got termination. That's basically kind of the same idea as the extends feature. Through wall is just going to go straight through your part. After the countersink of the counterbore is over, it's just going to go straight through. Distance, it's pretty explanatory. You've got to cap it at some point. So if I only wanted to go an inch down, it would give me this drop-down box. So it gives you a few more options to play with. This is a complicated tool, but with enough experience, it makes it pretty simple. So we're going to use a hole, kind of do the same thing we were doing before. We're going to create countersink. Patterns. Back to patterns. So click circular pattern. And the 3D patterns I actually prefer to the sketching patterns because they kind of come out a little bit more clean. They're a little easier to work with. They don't require as many inputs after the first one. So the circular pattern, you've got the features right here. You can go into your browser window right here and click the hole. You can see the hole is now highlighted. It's highlighted blue, so that's how you know you've clicked the right thing. Rotation axis. Let's say, so in this case, sometimes you'll have a part. Let's say you're doing this in the sketch mode, and you'll just click the center point of a circle. And that'll be your rotation axis. It's thinking about going around that point. But in this case, it's a 3D part. You kind of need to select somewhere else. So there's no real axis to click, but if you click the edge of the circle, it'll do the same thing. It'll select the center point axis of that circle and go all the way around. Additionally, you can click rotation axis, and let's say I wanted to go in origin. Because of the way we put our part on the center point we did our original extrusion, we can click the y-axis, and it does the same thing. So you've got a few options to play with, and that's why it's important to know what you want to do before you do it. So let's say we want to do 4 holes, and around maybe 270 degrees of the circle. Kind of see what it looks like. Let's say we want to make it 200. It's a little bit more clear. And if I want to go the other way, you just click that flip button. It goes the opposite direction. That's kind of the need to know about the circle. So we're just going to click OK on this. Got these cool extrusions all the way through, and they're all identical to one another. And you can go back and change this kind of thing. If you right click in the corner and click Edit Feature, it'll come back to this. So I want to change it to 3. Do that as well. All right. Rectangular is kind of the same. Mirror is pretty much the same. Nothing really special there. Well, let's say we want to check this revolve feature. What's that? So we're going to create a quick sketch. We're going to use the XY plane. Well, let's kind of head on with us. Now, we don't really have anything to work off right here, right? There's a center point there we can see, but that's not really what we're trying to do. We're going to try to create kind of like the vertical post. It's like if we're creating a lamp, for example. But how do we get there? We want to go on top of the base, not through the base. So if you click Project Geometry, which is this piece right here, it's a really useful tool. And then I click another piece of geometry that I have. Let's say a plane or a cylinder, maybe what we have right now. You can click this face, and you can see it's highlighted yellow, right? Now that means that those edges of that part that we just clicked are now a part of the sketch. So we can use it as we want. So if I wanted to click the edge of this sketch, now I can do that. And now that edge is going to have this point connected to it, as you can see. So the project geometry is pretty useful. Alright, so let's say we want to create a rectangle. We're going to use a 2-point. We're using the 2-point instead of the 3-point because we're just going vertically. Vertically and horizontally, just use the 2-point, makes your life a lot easier. So we're going to click the midpoint, and as you can see, it's kind of highlighted green, the cursor. Click that. Right here. Let's say we want to make this about 1 inch, and we'll make it 10 inches tall. Dimension. We lock down a point, so now it's fixed in movement and it's fixed in size. It is fully constrained. And you can see that everything, if I want to drag it around, doesn't work. And you can confirm this if you look in the bottom right corner here, it'll say fully constrained. That's a really useful tool. If you're kind of like, hey, this looks like it's done, but it says one constraint missing, you've got some work to do. Drag things around, find where it is. All right, so let's use this revolve feature. Extrude is E as a hotkey. I don't think I've mentioned that already, but if you click R, it's your revolve hotkey, and it'll open up a tab window that you should be able to find. So, profile, we've only got one profile again, so click, just automatically select that. Axis of rotation. Cool thing is you're working in a sketch right now, right? So you can select that line in the center here, and it'll become your axis of rotation. But like we said before, if we wanted to select something from the original stuff, the X, Y, whatever axis we needed, or another piece of geometry that we projected, we can still do that. But right now we're just going to click this because this is exactly what we want. We're going to go to our home view. Kind of look at it that way. And you can see they kind of give us an idea of what's going on here. So extends is kind of the same. It's a similar thing to what extrude was, right? Depending on how far you want to go and what you're trying to do, you're going to change that up. Full is just a full rotation. Pretty straightforward. But then there's other stuff too. Let's say I wanted to go only 90 degrees. I can do that. And if I wanted to flip it, it's the exact same thing as extrude. Direction 1 and direction 2. Arbitrarily placed, but easily flippable. Symmetric and asymmetric. So again, you have a lot of options to play with. 2 and 2 next. They're kind of the same thing. Just implemented slightly differently. I'm just going to kind of cover 2 really quickly. Basically, let's say you had 2 faces like this, and you're trying to connect the 2. Let's say you're going to put a post between them. You make a circle on one, and you kind of extrude it up. And I know we're revolve here, but just think about extrusion. It goes to the top. You click 2. If you click 2 and you select the face at the top there, it'll extrude from the face you made that plane all the way to that top. So I don't really have something useful to show you guys right now, but that's kind of the image if you can think about it in your head. And I can show you guys that later if you're looking for it. In this case, we're just going to create a full really quickly. So the profile means like the axis again. So gives you that preview. You know it's ready. Click OK. You've kind of got the axis down. So that's kind of it for revolve, but that's not really. Let's say we're trying to create a lamp again, just for discussing. What else do we need to do? We kind of need to create this like hooked piece, right? The adjustable portion of it. So that's what you're going to do a sweep. And what do you need for a sweep? You need a profile, as you had before, kind of the same idea where you have a circle or a rectangle that you want to use as your guide. But then a sweep needs a path, because the sweep can do curves and corners and kind of whatever you can think of. A sweep can probably do it. So in this case, we're going to create a sketch. So start a quick one. We're going to do it right on top of this. A circle. Kind of mimic the same thing. Let's say it's about 1 inch in diameter. Okay, done. Easy enough. Now, but you need a second sketch, and some of these features will require a second sketch. For example, sweep, loft, and rib or not rib, but sweep and loft should both require 2. So, got the first one done. Click sketch. Go to your X, Y, Z right now. Doesn't really matter which one. Just depends on what direction you're going to go. And then we're going to project geometry. We're going to kind of click the top of this piece right here, just because we get the line we kind of want to intersect the original plane. It makes it, this sweep creates itself much more easily if it intersects the original. So we're going to kind of click the center point of that line that we just projected. Say it goes this way. We're going to click 1.5 and then tab to say 30 degrees. All right, that line's made. Now let's say we wanted to do an arc. And arcs are kind of interesting. They can be kind of tough to figure out how to work, but they can be useful sometimes, like this one. A 3-point arc, the first 2 points you're going to select are kind of going to be your base points. You can see it's kind of creating a line. It's going to be the start and end of the arc. And then your third point is going to determine the radius. And you can see that as I drag mine further away, it creates a different shape. You can kind of see how to play with it. So you can kind of customize it as you see necessary. And we're going to look for the tangent point. So see, it's claiming its tangent now. If I go here, click the 2, it's already on. So great, it's already done. We'll select, this dimension is going to be 2 inches. And again, because it's not, since we fixed that point before, now it's stuck. So we can move it, but we don't, it's not fixed in its location. So we can't move the arc, we can't move the center point at this point. But we can move, because it's tangent, but we can move the end point. So we're going to kind of move it to right here. We kind of do another arc. Click the end there, click the end there. Tangent. 2. 5-inch radius. And we'll say this one lines up with this one. Okay, looks good enough. Finish that. So, kind of looks funky. You can kind of see how it should look at the end of it, right? So, if you click, no, that's sketch. S is not going to get you what you want here. You're just going to have to click the sweep feature. And you can see that gives you another pop-up box. And a sweep needs a profile and a path, right? We've got the profile. It's figured that out already because it's the only one that's a closed loop. But then it wants to select a path. And that path is going to be right here. As you can see, it's kind of populated that path already. It's giving us a preview of what it's going to look like. And you can see the circle kind of goes along, and it's going to give you this little indentation wherever the end of one surface is. You can see the end of the line kind of it lines up with this circle, and then it kind of changes over, and you can see it does a circle again. It does a circle at the end of this segment. So it's based off the segments of your path. We're just going to look at the path right now. We're not going to worry about parallel too much. You guys can explore that on your own. But taper and twist. If you, let's say we wanted to make this kind of slightly smaller as it goes along. If we put a 1/4 taper. Now you can see the dimension, the size of this part is going to change. Make it a little bit more obvious. You see the circle gets a lot bigger over the course of it. So we're going to put it that. Let's say we wanted to twist too. Maybe you can see the part kind of twists. The circle does. It doesn't make too much of a difference right now because, like I said, it's just a circle, but you can see the path kind of twists along. We're going to leave that at 0 though, and we're going to click OK. And that's the sweep. So the sweep kind of, if you need to create a handle for something or you're trying to do an odd shape, that's a really good tool to use. Other ones that are really useful. The loft is along the same lines, but it's kind of different. Let's say you have 2 circles. One's for, actually, let's just do it. So sketch, click right here, project the geometry, we want that. We click a circle. Kind of make this tangent to this one. Set a dimension, let's say it's 1.5. Beautiful, done. We should. Okay. Okay. We'll kind of leave it there for now. Green is bad, just as a general rule. Green is bad. We're going to use it here. So, use a loft. Let's say we create a sketch, and we create a sketch here. You're just going to kind of create a circle in the distance. Okay. Your 3D model, select loft. And then you kind of have to click multiple sections, because a loft, what it does is it'll take two profiles and then create a path between the two so that the end profile is what it looks like and the beginning profile is what it looks like. So in this case, the beginning profile looks like this circle right here. The end profile looks like this, so add another. There we go. You can see how it kind of looks. And that's your loft. So it's a really interesting tool. The one thing I would caution you with the loft I find is more useful than the sweep. It allows you to create the beginning and end points, versus the sweep you have to create the path. And it can be harder to use. But make sure you understand which situation you're in, because there are times where a sweep is a lot more valuable. If you're trying to do some kind of handle, a sweep is way more useful. But if you're trying to create like a funnel, a loft is much more ideal. So we're going to go over a couple more simpler ones, simpler tools. So for example, you got the fillet. I think this is pretty straightforward. If you just click the edge of a part, for example, if I click the edge of this, it'll highlight itself, click it. You can see it's kind of blue. And that's because if we zoom in, you can see it's got this curved edge now. Right? And you can apply that to multiple places. If you click here, click here, click here, yada yada. And now you can see that the edge is kind of curved. And you can do that multiple places. Chamfer is kind of along the same idea, except it's got a couple different options. You can do distance, which will create a perfect 45-degree triangle at the chamfer. Distance, angle, and two distances. Basically, you're creating a triangle of a surface and just cutting it out, like a cross section. So if we click the 2 dimensions right here, we select an 1/8 of an inch is perfect. Great. Click this edge, you can see it kind of creates a triangle instead of this curved surface. So it really depends what you're looking for. So click apply. Yeah, looks good. Great. Last thing that's really useful is the shell feature. So how do they make aluminum tubing? It's along the same lines as an 80/20, really is. It's an extrusion. But think about if you were trying to create a block of aluminum tube. You kind of want to make the piece, you want to make that square, and then you kind of want to cut out the rest of it. You want to keep that profile in the center and just eliminate the centerpiece. Or you want to keep the edges, but you want to eliminate the center. That's what shell does. It takes the inside of the part and completely removes it. So if I go in here and I select this face, and let's say this face. Now it's gonna remove those two faces, and then everything inside the part that's not included in the last piece of thickness that you specify right here. So if I say a 1/16 of an inch is the last I want to specify, and I click OK. Oh, it is the loft. Sometimes if it's too thin, it'll give you an error that, hey, this isn't actually going to work because the loft, it's just too thin for me to do a shell here. So let's say I click this face though. Really not liking that loft. Okay. There we go. Okay. So you can see it kind of gives you a preview of where it's going to cut away. You can see next to the holes, it's going to keep those features. So we're going to click OK for now. And it completely eliminates those points. The entire center, just the entire face is taken off. You can see inside of it, just like if you were going at an aluminum tube. You click one face, you click the other face, and then it'll take out that entire middle section and leave you with that square, perfect exactly as you wanted. And it's like if it was the face. It's not going to remove any extra thickness. So if you compare that chamfer to what we had before, it's not going to remove anything. That's still an 1/8 inch chamfer, but it's just going to act like that face was just never even there. So, for example, if we go into inspect, and you click the distance tool, really useful, and we click there, oops, I'm going to rotate this, but here, you can see it's still an 1/8 inch. That's a really useful tool. You can find a lot of. It's going to help with it's one of those things where, especially with aluminum tubing, for example, there's multiple ways to do everything, but that tool is especially useful for whenever you're trying to create some kind of cover or compartment. That is going to be your go-to source. There's multiple different ways to play around with it in the specific tool, so I'll let you guys go figure that out. But it's really, I find it extremely useful. Kind of covered patterns, mirrors, pretty much the same, except instead of a line, you have a plane. Nothing really special there. I think that's about it for 3D modeling. Does anyone have anything specific they want me to go over, or any questions? Okay, cool. All right, have I lost you guys? Am I going too fast? Am I going? Okay. Great. Crickets. All right. So we're gonna go into assemblies now, because I want to show you guys that. That's from a robot building perspective. That is where you're going to get 90% of your use out of. Yes, it's useful to create individual parts. It's cool to cut out cool logos. It's awesome to make these really nifty plates and really nifty parts, but if you don't put them in assembly, you kind of lose a lot of CAD. So this is where the majority of the most important stuff, but it's also not that complicated, which is really nice. So you just kind of click standard. Weldment is kind of not needed really. It's one of those things like sheet metal where you can get it if you want it, but you really don't need it. So standard is what you should go with normally. The first thing you're going to do with any assembly is you're going to place. And you can place in the content center. It should be something that you download with it. It's going to have various screws and belts and things like that, but almost always you're going to want to place your own parts. So just kind of click place. You'll find multiple different things to click. We're going to go to the folder I had up before. So we're going to click, you select one of the parts you need. We've got an axle, a bracket, and some tubing. But we're just going to click a bracket for right now. Right? So you can see the brackets right here. If you go to the home view, it kind of follows the same idea. So we're going to fix it right there. Right? So now the center point of that part, whatever it was in the part model, is now overlapped with the center point of this assembly space. So why is that important? Well, right now it isn't, but one thing I'm going to do before I even start, and I recommend doing this with any assembly, is whatever your base component is, right-click it in your browser, and find the grounded feature. Now what does that do? It means that no matter what you do the rest of your assembly, that part can't move. Everything is fixed to that part. So whatever references you make with your constraints, it's going to be stuck together. So it's that part that's key. If you start moving that part, like later I'll show, it's going to move the entire assembly around. It's going to be kind of, it shouldn't affect anything too critical, but at the same time it could move things like you don't want them to, or place them, and it could, if you're relying on the assembly planes for something, it can move the assembly planes places. So ground it. It makes a difference. Place, click axle and tubing. We're going to go with axle right now. So let's say I wanted 2 axles instead of just 1. Right now we definitely need the first one, but you can see it kind of creates a preview of that second one. If I click again and again and again and again and again, you can create you can create all of these, right? So if you just want to create one though, again, you just click place once, kind of undo them all, so you just need one right now. Place, the thing we're looking for is a piece of tubing, so click that. We've got all the components we need now. So, all the power of the assembly comes from these things called constraints. So click C is your hotkey, or you can click the constraint feature right here, and that's going to be where you're going to get 90% of this from. So there are multiple different types of constraints. You've got the mating, you've got the angles, tangents, inserts, and symmetry. Symmetry and insert, I don't find that useful, to be completely honest. Insert can be in the right circumstances, but I'm not really going to cover it here. It's something you guys can explore on your own. The other three I will cover. So, kind of quickly cover tangent because I don't really have the same parts for it. But basically, tangent is exactly like the constraints you had before in the sketching. You select a curved face and a flat face or another curved face, and they'll be tangent to each other. Except now you've got a couple different options to choose from. It's much more clear. If you want to create the tangent surface to the outside of another tangent, the other part of the tangent surfaces, you can do that. But if you want to do it inside as well, you can do that. So let's say I wanted to use the inside, right? I'm going to click the outside of that face, the inside of this one. And you can see that's kind of the inside. And now if I click this, it's the opposite. So it's kind of this flip feature that wasn't there on the other tangents, now it is. So you can kind of use it pretty effectively. So that's the basic gist of tangent. Offset is pretty straightforward. It moves it in a certain direction relative to the first face. So since the first face was the circular one, the second face is going to move. So click 1 inch, and it moves. So you click apply, and now that part will always stay 1 inch from being tangent, as you can see. Undo that, we don't really need it for now. Go back to the constraint window. The most important one you're going to find by far is mate. So the mate tool has two different ones, mate and flush, and they're kind of their own different things, but they're just basically opposites of each other. Mate's going to put two faces opposite, like I said before. So you can see the picture does a pretty good job of describing it. If I click this face and this face, you can see that now they're opposite one another. Right, if I offset it 1 inch, it makes it even more obvious. Those arrows point in opposite directions. If I click flush, however, now you can see they're kind of both facing the same direction. Really useful. They're unexceptional. But the mate tool is this hidden wonder. There are so many things in the mate tool that you'll find that the flush tool doesn't have. So for example, if I wanted to collect this face, I could do that. But let's say I wanted the center point of this face. If I go to the edge of that, I can click that too. If I want the edge of this part, this key, I can click that there. I want the top of the key, I can click that there. So the mate tool can apply a lot more things that the flush can't, as for example. See, I can't click edges or corners or center points. So the mate tool is going to be kind of this hidden it's like a hidden treasure box. You never know what you're going to find at the same time, so you can find some really cool stuff. So the most important one, however, is if you go over a curved surface, it'll select the axis that goes between that curved surface. So, for example, if I zoom in on this part, go back to this right here, right? I can't really collect that, but let's say I click it, come in here. Now it's selecting that face and that axis that runs through that cylinder. And why is that useful? Because now you can select another edge or another axis and line the two up. So let's say I wanted to go into the center of this part, and you can see I click this edge. Now those two axes are mated. So now when you're trying to put a circular, one of the keyed shafts into a circular bearing, now you can do that. It's so much easier. You see now it's always parallel, right? So let's say we want to select a certain distance for this from the back wall. I select flush, click the 2 points, and it'll set that flush distance. So probably like 2 inches away. Now you'll notice there's no flip feature in this one, right? You can't flip it in the opposite direction. So how do we change this? Offset accepts negative numbers. So instead of having to do the flip feature, you just do -2, it goes the other direction. In this case, we're going to select -0.5. Apply. If you click OK, it'll close the window. It'll still create the constraint, but it'll close the constraint window as well. So when you're doing multiple constraints at a time, use apply. Let me think. So let's do it again. Go to mate. Click those two again. Kind of see how this is working now, right? So there's one other thing I want to go over pretty quickly. Here's your angle. So it's probably more. I probably put it more useful than tangent and less useful than mate and flush. But the angle's going to allow you to fix things so that when you rotate, let's say you want to rotate that axle and you want to make the the tubing rotate with it, that's going to be your way to do it. If you use the angle constraint and you constrain their faces and planes to one another, it'll work. So along the same vein, we're going to try to do that. And how do we do that? Basically, like I said before, an assembly has its own planes. If I go to origin, those are the planes for the assembly, right? But if I go to this individual part, the tubing, it opens up the exact same drop-down window as I had before, except it doesn't include the how did I get there? How did I build it? So all the origins are still there, except for that they're this individual part. So we're going to use these to our advantage. Click C and get constraint back. Get the angle. A few different options. I'm not going to cover the last two right here. The one it originally selects is useful, but the one I find it to be useful and common, and it works just as well, is directed angle. You need two faces for this. So let's say we want to select the YZ plane. Now you can see it's selected, right? It's highlighted blue. Let's go into this axle and find the same thing, right? Now you can see that those are connected together. You can see it says 0 degrees right there. They're both parallel ones. So we're going to apply for a second. And if I rotate this around, right, you can see the axle rotates with it. It's even easier to see when you apply a flush constraint. We can leave it there. So now when you're moving parts around, you can show that, hey, when this elevator rotates to 5 degrees, we run into that tubing right there. We need to fix that. This is a really good way to see things like that. Keep in mind, however, if you can put more other assemblies into a larger assembly. So let's say you have an intake and you design the intake and you do that all by yourself, and then you want to put it in the real robot. You can take that intake and put it in the real robot. But if you've made the intake move somehow, it's not going to reflect that in the original one. So make sure that if you want to show functionality, try to do as many individual parts and do the motion in the largest assembly possible. I don't know if that's changed in later versions or not, so if someone knows, feel free to speak up, but I'm not 100% certain on that. All right, so those are kind of the major points on assembly. It's pretty easy, it's pretty straightforward, but like I said, that's the most important part. This is where you're going to get most of your use out of, especially in FRC and FTC. And VEX, if anybody's in here from VEX. I think that's about it. There's some cool stuff I'm going to go over in the next presentation where we go over bolted connections and gears and belts, and you'll find that stuff in design. There's plenty of videos online on how to do it. I'm going to cover it next week, so come back. And we'll go over some of the stuff in this section. But you're going to do all that kind of stuff in the assembly, not in individual parts. All right, that's about it for assembly. Any questions on assembly? Yes?
I don't actually have a question on assembly. I just wanted to know which specific programs are they using for doing the robots?
So it really depends. My high school team and the team that Grady High School works with right now, we use Inventor. So that's what I'm covering right now. That's what I'm using in this presentation. But for example, my brother's team in Virginia uses SolidWorks. I know a couple teams who use PTC Creo. I don't think anybody uses CATIA, but I've heard rumors that some teams do. So there's plenty of CAD programs you can use. It's just depending on what you can get access to. I'll cover that a little bit before we end here, but it's variable. Any other questions?
How close is Fusion 360 to Inventor?
Different. I can go over that more later, but it's different.
How do you change between units? Like if you want something in feet instead of inches?
Pretty simply, actually. So let's say I wanted to go into, let's go back to this. So right click, click edit. So you'll see this inches, right? UL doesn't mean anything. If you ever see that, it means unitless. So kind of ignore that. But let's say we wanted to set it in feet, for example. You can put FT. It'll recognize the unit abbreviation. So if I wanted to do it in millimeters, simple enough. So you just have to, what the difference is, instead of going into the part and then putting in just a number, which it'll default to inches in this case, you can have to put in a specific abbreviation, which can kind of get annoying. Which is a quick thing to show you guys. If you click the new button up here, it'll bring up this pop-up menu. You'll see templates. If you click the metric, it'll give you metric stuff. So if your team does things in millimeters, your team does things in meters, this is your way to go. And it'll default to millimeters instead of defaulting to inches like it's been doing this presentation. Any other questions? All right, cool. How are we doing on time?
It's 8 o'clock,
Okay.
so if you want to wrap up.
All right. I was going to cover working drawings. If anyone wants to stay a little bit longer after like the rest of the questions are over and go quickly over that, I'm happy to do that. I'm here till 8:30. So otherwise, that's pretty much all I have. So one thing I did was over the summer with 1648 was we did a few CAD presentations. They're pretty laid back. They're low key. But if you look up my name, T Davidson is my YouTube. They have a few videos from CAD on that, so it should cover some interesting CAD and sketching topics from the summer. There's general videos. Yes?
Also, I don't know what it all covers, but any of the Autodesk programs, like the AutoCAD, and they've got a ton of them, are all free with student licenses.
Yes.
If anyone wants to practice at home and not know that.
That's really, yes.
Just in FRC, do you see people doing metric or standard?
I see more people doing standard, but I think that's mostly because it's just a US team and everybody's kind of more used to inches. I know that when I came into high school, I never really thought about too many things in millimeters, so I can see where using inches is more popular. Obviously, all the international teams are going to go in millimeters. A lot of international groups are going to use millimeters. And in college and in industry, I found they kind of flip-flop between the two, just depending on who they're working with and where they're working with. So neither, especially where we live, I think it's neither a negative or a positive to choose millimeters or inches. But I think if you're working with a lot of international suppliers, millimeters might be a little bit easier. Anything else? Okay, cool. End of the presentation.
Will the slide deck be available?
Yeah, we can send it up.
So last thing is, why do we use Autodesk Inventor? Like I said, it's free. So, it's got a free education version. If you look up free software Autodesk Inventor, it should pop up with free. If you make an account on their website, they can give you free software. They don't spam you with emails. Trust me on that. But it's basically a free student license. It's active for 3 years, and you can kind of go back and download them again and again and again. So there's no real downside to that. They're our first robotics sponsor, so that's pretty cool. And Field CAD will come out in step files. So if you're using SolidWorks and and there's no way you guys are going to change that, that's okay. It'll come out in a step version. But if you want to do Autodesk and you're just deciding, this stuff will come straight out of it. So they will send out an Autodesk version with the assembly ready. So that makes life a little bit easier. At the end of the day, does it really matter? No. Because at the end of the day, they all kind of do the same thing if you do it right. They do things differently, and there's different ways that some programs they sell over others. But at the end of the day, if you choose to do SolidWorks, more power to you. It does not. It makes very little difference. Like I said, after the session, feel free to ping me. Those are my emails. So if you have any questions, feel free to ask away. I am available basically after work hours because I'm obviously co-oping this semester, not in school. So if I don't respond like immediately, it's okay. I will get to it. Just kind of make sure that you tag it. It's not like a regular email. And then kind of feel free to ask away if you have any questions now. And I'll be here till 8:30. So that's kind of it.